for more than a year. It's about 6 o'clock. The first three vehicles are lined up. And here is Highlander taking off, the number one seated vehicle of the Carnegie Mellon University at 6:30 in the morning, doing a nice little swerve in the beginning and then it's going off into the desert at really perfect kind of performance starting the race. Stanley has a little problem at the beginning, takes a little turn but recovers nicely and then essentially does the same thing as Highlander and disappears into the desert. The course was given to us about 2.5 hours earlier, at 4 o'clock. It's not a straight line, it's actually a very loopy course that basically starts and finishes in Primm. And DARPA made sure that the vehicles actually come by Primm so that they can be viewed as they're driving autonomously and then pictures can be broadcast around the world. So there's an initial loop of about something like 17 miles or so, and the vehicles just emerge from there. Sandstorm, Carnegie Mellon's second vehicle, set number 3 in the starting position. People paid relatively little attention to Sandstorm, even though it ended up coming in second, which is quite remarkable, and only 11 minutes after us at Stanford. This vehicle, as we now understand, was programmed to go a little bit slower than Highlander, so that if both Highlander and Stanley failed, Sandstorm would be able to bring home a safe win. Terramax, down the line, a fairly heavy machine. This is one of the 5 machines that actually arrived in the end next to Team Gray. And they arrived after about 12 hours the next day, but it's really remarkable that they were able to navigate this machine through the desert. This is footage taken by DARPA, not Bears. Stanley negotiating some sort of a turn somewhere. For most of us, you could only follow the race using an interface like this one from the web, where basically vehicles were being tracked. On the left side, the 3 dots that you see is Highlander first, second Stanley, and Sandstorm third. And you can see that at times Stanley gets really close to Highlander. At mile 102, the historic moment occurred where DARPA chose to stop Highlander and let Stanley pass it. This is footage from Stanley itself that we got access to after the race. And it's basically the passing going on in Stanley's own vision worldview. You can see how it swerves around the obstacle on the right side and then takes the lead in the race at this point. This is laser data, same thing. You can see how Highlander is being scanned by Stanley, a very rare encounter of one robot building a model of another robot. And you can see there's about a meter safety distance, which we felt was sufficient for passing obstacles or stopped vehicles. And Stanley then just goes off into the desert, and the rest, I guess, by now is history. This is footage that DARPA took of a pass called Beer Bottle Pass. It's a mountain pass, largely thought to be the most difficult part of the terrain. It's at the very end of the race, it's about 120 or so miles in, the idea was that if vehicles aren't able to negotiate it, then at least DARPA could report a substantial improvement in total miles gone. Now it turned out that all 5 vehicles that entered Beer Bottle Pass exited without any problems. That's just an amazing result for all of us in the community that we've been able to build 5 cars that went that far and all of them were able to negotiate stuff like this. This is a really steep cliff on the right side here. Stanley cruises at the speed that's basically the maximum velocity legal for the specific mountain pass. So I think it's 10 or 15 miles an hour, I don't quite know. It's interesting to us, we looked at this, we felt that this was actually a relatively easy mountain pass. We've trained certainly on much, much harder terrain than that. It's easy because the road itself is flat as a pancake. There's not really much stuff on there, there's no ruts, there's no vegetation, which really helps Stanley making its decision. The other thing is, on the left side, there's actually quite a substantial berm, and that berm might look small on video, but it's actually big enough for Stanley to really see it. And to Stanley, the berm looks just like the wall on the right side, so there's almost no chance it could fall down the cliff unless there was a major bug somewhere that we didn't know about. But it was reassuring. You can imagine this was live footage in the tent. We could watch Stanley to be the first to traverse this mountain pass. The crowd was cheering. It was just a really amazing moment to see that this is possible. I think everybody was taken seeing Stanley and then the other 4 vehicles taking terrain like this. But half an hour later, just below 7 hours total, Stanley was the first to emerge from the desert. On the left, this is the official finishing line. You can see Tony Tether waving his flag as if the car could possibly see him and react to him. And then a few final meters just to make Stanley drive towards the crowd. You can see Stanley's own view on the right upper side. And the rest is really history. Stanley arrived first from the desert after 6 hours, 54 minutes. Even though it started second into the race, and the people, like this is a picture of Mike and me, were so incredibly happy, many of us, that we were able to get a car out of the desert this fast. This is the final ceremony. I think that the important thing here is, I mean, we might have won, we got the $2 million check here, but it's really been us as a field that has been able to develop 5 vehicles that did this. And even though we were slightly faster, I think all of us did a fantastic job. I think it's really a joint victory for all of us.
Yeah, that's the first successful computer car racing in 2005. In 2004, now the car finished the race. In 2005, all the cars finished the race, and the Stanford team finished first. It's finished about 140 miles in 7 hours, so it's about 20 miles per hour in that desert. So that's pretty amazing, at least at the time. Later, they have so-called, in 2007, they have so-called urban challenge to drive the car in the urban situation. It's also Stanford.
Here's a car that really puts the auto back into automobile. It's a 2006 VW Passat, and it is moving around this parking lot without a driver. No human is inside it, and no one is steering it by remote control. Nicknamed Junior, this robot car probes its environment with rotating laser scanners, which paint a 360-degree image of the surroundings 10 times a second. Then Junior decides for himself, using artificial intelligence software running on powerful computers, just how best to proceed along the route that has been assigned to him. Sebastian Thrun leads the Stanford engineering team that's teaching Junior how to drive.
We have to build cars that can understand the world, they can understand other vehicles, sense them, perceive them, make predictions, and interact with them. So we have to understand if you come to a stop sign, that the other car might be there first, it might want to go first, there are certain rules that govern regular traffic, and we have to be able to adhere to these rules. So we have to make machines that replicate human thinking in that specific domain.
Watching Junior's every move is a group of inspectors from the government's Defense Advanced Research Projects Agency, DARPA for short. They're the serious-looking guys in the white shirts. They've come to Mountain View to evaluate Junior, to test its ability to maneuver in city street conditions along a course laid out on a parking lot at Shoreline Amphitheater. Stanford won't know until August, but if Junior performs to the DARPA judge's satisfaction, then the team can advance to the next round in DARPA's Urban Challenge, when, on November 3, as many as 20 robot car building teams will compete for a $2 million grand prize. For the most part, Junior ran his routes without a problem. But at one point, he simply stopped and refused to go around a parked car. Apparently, his computer brain was programmed with a little too much caution. After finishing the other tests, DARPA let Team Stanford and Junior have another go at it. Again, as he approached the parked car, Junior stopped and seemed to give the situation careful thought. This time, however, a more confident Junior drove right around the stopped vehicle. After his test drives were over, Junior got rock star treatment from the media.
Okay, so this is Junior.
Sebastian Thrun, clearly pleased with Junior's performance, showed off the car's main features.
It's equipped for driving by a computer. And the way you see this, first you see the whole trunk is full of computers. We can open it for you a sec. You see a computer system where the trunk